Question 9. Gwenda enjoys road running. She keeps a record of her run each day this week. So on Sunday, she ran 4.6 kilometres and it took her 26 minutes. Monday, 5.14 kilometres in 31 minutes. Last week, her average speed for the week was 9.6 kilometres per hour. Calculate Gwenda's percentage improvement in her average speed from last week to this week. So percentage improvement, to work out percentage improvement or any percentage increase, is your actual improvement over your original, which would be last week's, right? So over the original amount, and then multiply by 100. Problem is, we know our average speed for last week, but to work out the actual improvement, all right, and their average speed would be the original amount, which would be 9.6. We now need to work out how much she's improved by. So we need to work out her average speed for this week. And her average speed for this week is 4.6, because you should remember the speed is distance over time. So it's 4.6 plus 5.4 plus 2.2 plus 6.2 plus 7.2 plus 2.2 plus 3.4. And when you add that up, okay, it comes to, with a calculator, right, so I got 4.6 plus 5.4 plus 2.2 plus 6.2 plus 7.2 plus 2.2 plus 3.4, and that comes to, well, when I did it then it's 72.6, so I made a mistake, so let's try it again. 4.6 plus 5.4 plus 2.2 plus 6.2 plus 7.2 plus 2.2 plus 3.4, and that's better. So she's done 31.2 kilometers that week, and time taken would be, if we add up the minutes, 26 plus 31 plus 12 plus 35 plus 40 plus 14 plus 22, and that's in 180 minutes. 180 minutes is 3 hours, so it's 31.2 divided by 3. So our average speed is 31.2 divided by 3, which is 10.4. So our average speed last week was 9.6. It now becomes 10.4. So the improvement is 10.4, her new speed, take away last week's speed, which is 9.6. 10.4 take away 9.6 is 0.8. So if I go back to my original formula, it's 0.8 divided by 9.6 multiplied by 100. So on the calculator, 0.8 divided by 9.6 multiplied by 100 is 8.33%. Okay, so she's improved by 8.3%. Part B. The diagram shows a cross-section of one part of her run. Alright, so that's the hill she's running up, and that's the cross-section of the hill. Calculate the angle of elevation. Elevation, to elevate, means to go up. The angle of elevation is the angle you look up. So I'm finding this angle in here. In terms of this question, to find an angle, well, you know two sides in a right angle triangle is something called trigonometry. And if you remember from trigonometry is SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Alright, so I label a side. Opposite the angle is called the opposite. The longer side and opposite the right angle is the hypotenuse. And the third side is the adjacent. You tick off the side you know and the two sides you know this time, so there's an angle. So I'm ticking off over opposite because I know that it's next to 200. and I'm ticking off A for adjacent. So that means the only one with 2 ticked off is tower. So tower means tan of the angle is O for opposite over A for adjacent. So tan theta is 200 over 1600. So 200 divided by 1600 is 0.125. And to find the angle, you press shift tan. You do tan to the -1 of that answer. So shift tan of 0.125 equals, and the answer to that one is 7.1 degrees. Part C. Gwenda runs on another section of uneven road from A to B. The rise in this section is 300 meters. The angle of elevation is 10 degrees. So this time the angle is 10 degrees. Calculate an estimate on how far she has run. So she's running up the hill. So we're going to estimate to find this. Label a triangle before. Longer side is the hypotenuse. Opposite the angle is the opposite. And the third side is the adjacent. Write down SOHCAHTOA. We tick off the side we know, which is opposite, but this time we want to find hypotenuse. So I'm doing so. If you remember from so, sine of the angle is O for opposite because that's next, over H, which is last, for hypotenuse. So sin of the angle, which is 10, is equal to the opposite, which is 300, divided by the question mark, the hypotenuse. To find what that hypotenuse is, what you do, if you remember, when it's on the bottom, you swap them over and divide. So it becomes you flip them over and swap them over, so it becomes 300 divided by sin 10. Don't press shift or anything with this one. So you do 300 divided by sin 10 equals, and the answer to that is 1727.6 meters. State any assumption you have made. So an assumption I would have made there is the road is straight, because I'm assuming it's a straight line. It's a straight, there's no, like if you look at it in reality, there's little waves on it. So I'm assuming the road is straight. Okay, because she runs in a straight line. But what is the impact of your assumption? My answer is going to be longer, all right? My run is shorter. Her real run is going to be longer because she's not going to be running on a dead straight hill. She's going to be going up and down over little sort of hills and bumps. So a real run will be longer than my assumption, because she's not going to be going straight. She's going to be going up over little bumps and hills or around them. Okay, thank you.